What's up, 7th graders?
Oh, Miss Talati, you sound so blah, blah, blah. Hi, it's Miss Cervantes.
And Mrs. Talati. And together we are
Mrs. Cervati.
Today we're covering 6.2, one-step equations with rational coefficients. Now, this is the same video for Math 7 and 7-8. So Math 7 students, you guys have had quite a bit of practice with one step with integers. 7-8, you're going to have to kind of jump in and follow the rules. So we are going to include, I think theirs has inverse operations, but not coefficient. We just covered coefficient today. So remember, inverse operations are operations that undo.
Do and undo each other.
Do and undo each other. So,
tie and untie.
We look at addition. Now, Cervantes, are your students still struggling with the idea that a subtraction and a negative are virtually the same thing? Okay, so
they got a little bit better once we were grouping.
Right, with the signs.
With the sign to the left on combining like terms.
But I want to go back, you guys, just as an example. Like if we had this problem, just a basic primary problem. If you guys were in first grade, that'd be 3 minus 2, right? But we taught you in math this year that you can keep change into 3 plus a negative 2.
So adding the opposite
is the
same thing. They're not recognizing it's the same thing. Yeah.
So 3 minus 2 is the same thing as 3 plus a negative 2. It's the sign in front of the number. So I think.
Well, and the thing about it is, wouldn't you rather get rid of, do you want a plus a negative, or it's just easier to have minus 2. Have one sign. I told them you don't want to have 2 signs next to each other. It makes it more complicated.
So keep that in mind because we're going to get into the one step. Remember, your coefficient is a number multiplied by a variable. So if we have 4x, it's a 4. If we have 4y, it's a 4. If we have 4xy, it's a 4. If we have 4b plus 3, it's only the 4.
Yep. And then your coefficient, that number, it could be 4, it could be a negative integer, it could be a fraction, it could be a decimal, it could be any rational number.
4/3 x.
Yeah. So your coefficient is just whatever rational number is being multiplied by the variable.
Okay, so we want to go back. Well, we'll kind of get into this. So 7-8 again. Some of this is going to seem kind of new, and I'm going to do one way, and Cervantes will do her way as far as balancing the equation. So our job is to isolate the variable, which means we want to solve for the variable, right? If I look at the x plus 3.2 equals negative 5.8, and I cover up my x, you can't see me cover it up, but they can't see. Can they see a shadow on the thing?
Oh, no, they can't.
Okay. I want this x to be by itself, right? Well, this positive 3.2 is on the same side. So in order to get that x by itself, I'm going to subtract a 3.2 from both sides. A positive 3.2 and a negative 3.2 zero out, so I bring down my x equals. And now we got to go back to some of these rules. Same signs, add, keep sign. We're still struggling with some of those rules, right? So I'm going to add these. I get 5 plus 2 is 7. Bring down my decimal. 8 plus 3 is 11. And I keep sign. Now, to check these, and I had a student today that really caught himself when he was checking that some of them didn't make sense. When I check, this 11.7 is going to replace my x. So I have a negative 11.7 plus a 3.2. Well, if you stop there and identify that these have different signs, so I'm going to subtract and take the sign of the bigger number, you can see that this answer checked out to my negative 8.5 in the original problem. So my final answer is this, x equals negative 11.7.
Yep. No, the only thing I figured out is, you know how they have trouble when you get here? If you have negative 2x equals 4, and they start trying to divide by the opposite.
Yeah.
Okay, so I kind of figured out as you're explaining it, what's the inverse of add? Subtract, and then and what do you want to get rid of? 3.2. So then it's minus 3.2. Instead of saying subtracting 3.2, or I used to say, what do you pair with positive 3.2, negative 3.2? Then they think down here that they do opposite signs. And now I instead just say, what do you want to get rid of?
Okay.
You want to get rid of -2, so you divide by -2. So then here, what's the opposite of add? Subtract, and then what do you want to get rid of? 3.2. Then they're not using different signs here.
Gotcha.
So I caught them on that today,
Yeah.
and that seemed to help. I don't know why. Just like a little bit of wording. All right, you want me to do the next one?
Sure.
Hopefully that wasn't confusing. Okay, so -2/3 plus y equals 8. Same idea, follow all of your same rules. -2/3, we want y all by itself. So if you want, if you want y all by itself, how do you, this is a negative, so you want to pair it with a positive, or you can think of it minus plus, however you want. What do you want to get rid of? 2/3. What you do to one side, remember this is your middle, you do to the other, so you're adding 2/3 to this side as well. -2/3 and +2/3 cancel. You get y equals, and then 8 2/3 is 8 2/3. And that one's easy because positive plus a positive. And then if you're checking your answer.
Well, and I was gonna go back, if we just go back to reviewing of fractions, because we will have ones that don't work out so nicely. Remember, this common denominator is 3, so this gives me a 3 here.
Oh, yeah.
And then I have a 2/3, so if I add these together, I get a 26/3. Well, if I turn this into a mixed number, this is where I get the 8 2/3. So don't forget that you will have to find common denominators.
Yeah, this one was pretty easy.
Yeah.
Okay, and then checking it is easy too. So if you have a -2/3 plus 8 2/3 equals, and then you know your 2/3 and -2/3 cancel, so you know you have 8 left, and then that works. So you could go ahead and then say that's your answer. Okay, don't forget to check them. I forgot to check it right away.
All right, so this is where my kiddos struggled, because they see this negative sign and immediately want to add.
Yep.
But this is a coefficient, right? So this is a -0.5a times a, which means the inverse operation of multiplication is division. We want this not to necessarily zero out, but to cancel out and give us a value, which is the same thing as a 1. You don't have to write the 1, you can write the 1, it's up to you. But remember, just because it has a negative sign does not mean that you're going to add it. This is multiplication.
Yeah, so think about what I told my kids is the first thing you look at is your variable term or your variable and see how is that number connected to it. How are they tied together? They're tied through multiplication, and then that's division. And then remember, division is the inverse operation. Don't do a positive here because that's negative. The inverse part is the division. Then what do you want to get rid of? -0.5. So divide by -0.5.
So then this is a 30 on the inside divided by a 0.5. Remember, we have to move this over 1, add a 0. 5 can't go in here, 5 goes in 6. We multiply and get a 30, but we bring it down. So then we should get a -60. So you can see there's lots of room for error as far as division of decimals go. But if you go back and check it, we should see that a 60 times a 0.5 gives us the 30. So again, when you plug it back in and check your solution, hopefully that's where you catch. If you got a 6 here, that's not the correct answer when you multiply it back in.
Yeah, you shouldn't get these wrong because you're your own answer key, right? You checking them by checking them?
Okay. We always tell them in algebra you can guarantee you're right on everything just by checking it.
Right. Okay, let's look at this one. So the negative's out front here. Normally I attach my negative to my numerator, but in this one I don't want to have the -a. So I'm going to attach it to my denominator and rewrite it as a over -3.5 equals 9.2. And then recognize that this is a division problem and the inverse is multiply. And then what do you want to get rid of? -3.5 over 1. Those cancel, you're left with a over 1, which is just a. What you do to one side, you do to the other. So multiply by -3.5 there. 9.2 by 3.5. 10, 46. 0, don't forget to do this step. Some of my kids all have one line. 3 times 2 is 6. 3 times 9 is 27. If I add, sorry, I'm going to come down here, 12, 8, 12, 3. How many decimal places? 2. So 32.2, and then it's a negative and a positive, so it's -32.2. You can add the 0 on there if you want. Okay? And then check your answer. So you would do 32.2 divided by 3.5. Don't forget to move your decimal, bring it up. What do we get? 0, 0, 35 into 322. How many times? Let's try 9. I can cheat because I'm looking right here. Just check it. 27 and 4 is what? 31? 315? Are you checking my math? 7, add a 0. Let's do 9 there. I forgot my 9. Add a 0, bring it down. And then 2, so 9.2.
Perfect.
And then let's look at our signs. A negative divided by a negative is a positive, and that's 9.2. So that works. So you could check it. I always check when I checked it. So negative 32.2.
So you guys can see these are stepping up. You got to really pay attention to fractions, decimals, positives, negatives.
Well,
inverse
division is
operation.
where we got killed in the rational numbers unit.
Mhm.
So you do need to be practicing your division again.
And again, you guys can see why everything's rolling back. All right, a scuba diver is exploring an elevation of negative 12.2 meters. As the diver rises to the surface, she plans to stop and rest briefly at the reef that has an elevation of negative 4.55 meters. Find the vertical distance. I want to see, this is the one that they give us a picture in, don't they?
I just walked right past.
Yeah, you're all right. So if you guys look,
yes, there's
yeah.
on what page though?
Let's look. This is one where you guys might want to look back on page 180 of your textbook. They give you a little picture of the ocean. I'll kind of do a generic one here, but basically they have, that's the water level, right? Then we have is that a negative 4.55 meters? And then down, and this is what are we looking at?
Diver.
Oh, the reef. I don't know how to draw a reef. I think they just did like here's your reef.
Okay.
And then here's the diver at negative 12. Oh, I get to draw a stick figure. Here's your diver. Okay, so again, look at the textbook because it's a lot better than Pilates. So our equation is going to be where the diver is and where the diver needs to get to the reef. Okay, so again, we're going to write the equation. X is going to be the vertical distance between the elevation of the diver and the elevation of the reef, which, let's just change this color. It's kind of like right here, right? So then we just solve this. We're going to balance the equation. We want to isolate the x, so I'm going to add, because the opposite of the, look at, I have to line my decimals up. 12.2 here. So these are going to cancel out, bring down my x equals. And then these are now, you guys, this is where we got to pay attention because these are different signs, but decimals. So I have to put my 12.2 on top and line up, because I have to subtract and borrow. Again, why we spent so much time on rational numbers. So then we should get a positive 11.65. Let me double check my math on that one. That one was 0, 1, 12, 1. Yep, 2, okay. So then if you think about it, there is 11.65 meters in between the reef height, or the reef depth and the diver's depth. And then if I check that, I'll do this in a different color. Negative 12.2 plus an 11.65. Again, different signs, so you have to line them up. There's my 11.2, my 12.2, and my 11.65.
Yep, we're off.
What did I do wrong?
Subtraction. 5.
Oh.
Do your
Good.
subtraction
See?
again.
Right here.
Yes.
Because I was, this is a 7.
Yeah, there you go.
Because then look at, when I go to, see, this is the prime example, you guys. When I was checking it, it wasn't working out. So right there would be a ding, ding,
But
ding.
you kind of knew before you even got that far. So follow your gut, you guys. Remember you stopped and you said,
yeah, something was going wrong. But
Yes.
even when I checked it, I wasn't just going through the motions. I was actually checking my math. So now, let's see if I get it right. 7.65. There's a 5, a 1, and a 5, and a 4. Perfect. So
Yeah.
there's my, and then the negative because it's a bigger number.
right.
Thanks, Cervantes.
No, I didn't see it at first either.
No, but
Okay.
when I checked it, it came out wrong. So then I was like, man.
All right, let's look at the example 3. That's on page 181. It says between the hours of 10 p.m. and 6 a.m., the temperature decreases an average of 3/4 of a degree per hour. So here's the way I write that already. It decreases 3/4 of a degree per hour. how many minutes will it take for the temperature to decrease by 5 degrees? So how many minutes, so x is minutes, so let x equal minutes. Oh, you know what?
What?
This is a good one. X isn't your minutes. X is your hours because it's degree per hour. But then we want our answer in minutes, okay? So X, when you start this off, is in hours, okay? So it's down, it decreases 3/4 of a degree per hour. How long until that's equal to -5 degrees? So how long for it to decrease 5 degrees? So, and I don't know that we've done one of these where you're getting rid of the whole fraction. Are you all right just multiplying by the reciprocal with yours?
Yeah.
Okay, you don't do a two-step?
No,
Okay.
not yet.
Okay, so if we're looking here, this is -3/4 times x. One-step equation. How do we wipe out -3/4 all at once? You multiply by the reciprocal, -4/3. When you multiply, look what happens when you multiply by the reciprocal. Remember your rule to keep it balanced. What you do to one side, you do to the other. So you have to multiply by -4/3 on the other side. You can make -5 look like a fraction if that helps you. So then you have x equals, and -5 times -4 is +20/3. And x is hours. So that's hours. But we want to go to minutes because it's saying how many minutes. So pay attention to your question because I almost missed it in the beginning too. So hours to minutes. So wouldn't it be 20/3 times 60 minutes over 1 hour? Okay, so you can convert it that way. So 20 times, and you can reduce here if you want. You can cross reduce here to 20. So what is that?
400.
400 minutes. So 20 times 20, 400 minutes is how long to decrease. What is it, 5 degrees? 5 degrees Fahrenheit. Okay?
Perfect.
All right, so just pay attention to your question that it's giving you in per hour, and you need to know how many minutes. So you can calculate it per hour for your ratio, and then convert that over to minutes because 60 minutes is 1 hour. Okay?
All right, so now this is where it's a little different. So Math 7 and 7, you both have the same 3 computation. And then Math 7, these are your 2, and Math 7A, you have 3. You guys, use the examples that Cervantes and I did to help guide you on the additional practice like we've said before. All right? And we'll have plenty of time to practice these. Have a great day.
Bye.